Thank you very much, Professor Assunta Bertassini. My presentation is going to be on the transmission trials that we did in Jamaica on Oecleus mackaspringii. I'll first go through introduction. And then I will go through the rest of my presentation. Well, we know phytoplasma where it is located, so I don't need to go through that. We know that phytoplasma vector of coconut mostly belongs to the 60-day. The aim of this work is to collect potential insect vectors and to investigate if the new insect vector, Oecleus mackaspringii, which I discovered in Jamaica, transmit the LY phytoplasma in cages. I want to pause here though and say that this work could not be undertaken without the help of my colleagues from University of Florida, Professor Bader and Erica Hemlick. Thanks. This is a general map of Jamaica where coconuts are located, and the yellow areas that you see indicated on the map here is where you have the lethal alien disease mostly in the coconut growing areas. We conducted surveys for insects in some of the areas, and the star on the map suggests the areas we collect the insects: Spring Garden, Kilmurray, Kildare, Hope Bay, Bartnaz, and Harthill. These collections were done by myself and in collaboration with my colleagues from the University of Florida. The location and the number of insects collected in survey, this is an approximation because we don't have the exact number because we're still counting. The total number of insects approximately is about 968, and those are the various areas and the numbers that we collected from those areas. Continue, please. These are my colleagues in the field. Professor Bader on your extreme left, in the middle there, setting up an experiment that we did in the field. And you have Erica collecting insects in her sweep net. And of course, myself using aspirator to collect Oecleus mackaspringii from the coconut leaf. The potential vector that we generally know is the Haplexus crudus. This work was undertaken by Bill Howard, University of Florida. And continue. Yes, so the Haplexus crudus was first discovered in Jamaica in 1907. All right, that was the first time Haplexus crudus was named by Van Dusse, and that was done in Jamaica. We found a new insect. The reason why I mentioned that is to set the context in which this insect was found. We found a new insect in this area, Spring Garden. The yellow box that you see there is Coconut Industrial Board's farm. And we sent the insect for identification. It was actually done by Professor Bader of University of Florida, and also with Charles Bartlett. It could not have been done without their efforts. Thanks. This is general methodology that we use when we collect insect: field collection, morphological observation, and then we do DNA extractions, and it goes both ways to check on phytoplasma detection, and then to look at the cytochrome C oxidase subunit 1 to see what difference are there, or we use the 18S RNA gene. Continue, please. So this is the new insect. I discovered the new insect in the Oecleus genus. I named the insect Oecleus mackaspringii, macka meaning patois, and springii from where it is from, Spring Garden. And the work was published in Zootaxa. Continue, please. This is a phylogenetic tree, which shows that the insect is completely different. It's a 66 such species in the world. That we found in Jamaica. Continue. So field observation for this insect. Observe the insect on coconut leaves. It is not a pest of the coconut tree. It is found distributed so far in 4 areas. And I know over time we will find it in other areas as well. The nymph of the Oecleus mackaspringii was also found on guinea grass. And I observed, if you look at the leaf that I'm holding in my hand, that's a spider that was actually feeding on the Oecleus mackaspringii. I'm saying Oecleus, it's not Oecleus, it's Oecleus, and the Oecleus mackaspringii. On this field observation, we found Oecleus to be enjoying themselves. This is the Oecleus actually mating on the leaves, female and male, having very close intimate association on the leaf there. And on the other picture, you have Aplexus crudus. Continue, please. The number of insects that we collected and used for PCR and digital PCR, those are the numbers. Those insects we collect is approximately 155, and those are how they are divided by Professor Bader, and looking at the cerebral and body and head to see if the LY phytoplasma is actually amplified from these various regions. Continue, please. The same thing here, continue. We also found another new insect. It was found by Professor Bader. He gave me the opportunity to name the insect. I named the insect Agubini in honor of my research director who went on retirement some years ago, Mr. Bean. And this was actually published in Zootaxa. Continue. Yes. Very nice gentleman. Transmission field trials. We conducted transmission field trials. You can see the cages there. We generally do a sweeping, to collect the insect, or use aspirator to collect the insect. Then we put the insect in these cages. All right. We have a cage that we put no insect. It's a control cage. And then we have other cages that we put the insects in. And then we observe the plants over time to see if they develop symptoms. And I won't mention how close we are to having transmission, but someday we will have transmission, I think. Continue, please. That's the general transmission cycle of the phytoplasma insect. When it is acquired by the insect, it goes through a process of multiplication within insects for it to get to the salivary glands, for it to be injected. I normally use an analogy when I'm talking about this. For example, a mosquito taking up the plasmodium that causes malaria. And when it takes up the plasmodium that causes malaria, it goes to somebody else, inject the plasmodium in that person, and the person gets malaria. So it's just a similar process that takes place here. The healthy tree will become infected, just to say that it is not efficient. If it was efficient, a lot more coconuts within a plot would have died in a linear fashion. It's not efficient. And you'll see when on previous slide, I will show you, on other slides, I will show you how the spread of the disease occur. Continue, please. Okay, here is it. This is a jump spread, which I call. So you have one lethal alien tree being affected by lethal alien, but then you have several trees that are in between that are not affected. So it is not, the efficiency of the insect is not very great. And then you have a direct spread as well in some cases. Continue. This is just to show a correlation between the months of the years and how environmental factor actually plays in the density of the insect and the amount of trees that are going to be infected by the insect. Incidentally, the low density that you see there in 2010 is not by chance. In that year, we had a hurricane. We had a lot of rainfall. And so, in situations like those, you don't expect the insect to be efficient in transmitting the disease. So the number of palms being affected would be very low, and that continues over 2 or 3 years. Continue, please. The last slide here is just to show what can be done when you use simple technology. If you look at the picture on your right, I can't plant coconut tree for my life, but if you look on the picture on your right, I was using an implement to actually go up on the coconut tree where I could pick the coconut myself. This gentleman was from India, and he taught us how to use this implement. Thank you very much for your attention. I want to say this appreciation to the following institutions who helped us over the years with our research work. Thank you.